Hello, my name is Craig Hancock. I'm the project manager for the Heber Valley Corridor Environmental Impact Statement, or EIS.
Hi, I'm Naomi Keeson, the Environmental Manager for the EIS. We'll be walking you through a summary of the Addendum to the Final Alternatives Development and Screening Report and talking about what to expect next from the study.
All the information that we'll be talking about can be found on our project website. So thanks for being here, and let's get started.
A project's purpose and need is the reason for the project and what we are trying to accomplish. The purpose of this project is to improve regional and local mobility on US 40 from SR 32 to US 189 and provide opportunities for non-motorized transportation while allowing Heber City to meet their vision for the historic town center. We developed the purpose and need back in 2021, and it hasn't changed. The purpose defines the goals the study will address. It drives the environmental study process because it lays a foundation for the types of alternatives to be developed and analyzed. The purpose was developed based on previous studies, traffic analysis, as well as input from stakeholders, agencies, and the public. We published a draft purpose for public and agency comment in the spring of 2021, and based on the comments we received, we decided to add non-motorized transportation as a primary purpose. The study's purpose has 4 key parts: regional mobility, local mobility, non-motorized transportation, and Heber City's vision for the historic town center.
Every 4 years, the Regional Travel Demand Model is updated by the Rural Planning Organization. In this area, the Mountain Land Association of Governments, or MAG, with the latest approved growth projections and planned transportation improvements. A travel demand model is a computer model that predicts the number of transportation trips in an area at a given time. This prediction is based on the area's expected population, employment, household, land use, and road network conditions, which are based on development and growth patterns that are approved by the local governments. Usually, new models validate assumptions and results from previous models, so UDOT can rely on decisions based on previous models to keep moving forward. In October 2023, we had a draft EIS almost ready to publish when MAG's Wasatch Summit Travel Demand Model was updated. The old Wasatch Summit model did not include all approved developments east of North US 40 or in the Mayflower area. Additional growth assumed in the new model resulted in 30% more traffic on North US 40 and 10% more traffic on Main Street in downtown Heber City compared to the previous model. This change in projected 2050 traffic delayed the EIS process while the new travel demand model was calibrated and finalized, and the implications to 2023 alternatives we previously had developed and screened were analyzed. We took our time and carefully analyzed the new data to assure our proposed improvements met the current and future travel needs of the community. Back in 2023, we had 5 action alternatives that were being evaluated in detail, shown here. All 5 were west alternatives, and the main difference between them were whether the northern portion included improvements on existing US 40 or as a new road all the way to SR 32, whether or not US 189 was realigned on the south end, whether it was a freeway with interchanges, meaning intersections would cross over or under each other with bridges or ramps, or a highway with signalized intersections. Previously, we did have one freeway facility with grade-separated interchanges, which was WA1. The other 4 were at-grade highway facilities with signalized intersections. Based on the updated traffic model I mentioned earlier, the 5 alternatives designed in 2023 were not sufficient to accommodate the larger projected traffic volumes and needed additional capacity improvements. WA1 was already a grade-separated option that proposed a new freeway along the west corridor, linking it up with the existing US 40 to the north. It was designed for smoother traffic flow by removing at-grade crossings on the new corridor itself. However, US 40 and US 189 would still have signalized intersections. And to make it work, we needed a key east-west connection at 1300 South to tie everything together, which is needed for all the alternatives. The updated traffic model projects that by 2050, the highest volumes will be on US 40, north of downtown Heber City. We expect nearly 50,000 vehicles per day, similar to Bangerter Highway today. With these volumes, we needed to make adjustments to WA1 and the WB alternatives to meet the travel demand. The new 2050 traffic volumes are large enough to consider grade separation for all our options. Because vehicles would not need to stop with grade separation, we refer to these as free-flow alternatives. We created a free-flow variation for the 4 at-grade alternatives which are WB1, WB2, WB3, and WB4. The free flow variations remove at-grade signals, convert intersections to interchanges, and add directional ramps to connect the new corridor to existing roads, such as US 40 and US 189. Access would only be allowed at interchanges or directional ramps. The 2023 WA1 alternative already featured many similar elements as the WB1 free flow alternative and was considered redundant, so we improved it to become Alternative WB1 Free Flow. So we had 4 at-grade alternatives and 4 free flow counterparts for a total of 8 alternatives we took through the screening process. The at-grade alternatives for WB1 and WB3 have been updated to improve traffic flow on US 40 north of Heber City. To achieve this, we've added capacity by either widening US 40, adding turn lanes, or a mix of both, depending on the specific alternative. The main difference between these 2 alternatives is that WB1, shown on the left, includes improvements on existing US 40, and WB3, shown on the right, includes a new road all the way to SR 32. Both of these alternatives include signalized intersections on North US 40 at SR 32, University Avenue, Commons Boulevard, Coyote Canyon Parkway, and 900 North. These are similar to the alternatives that were considered in 2023, except for WB1, North US 40 would be widened to 3 lanes in each direction, with a raised median and added turn lanes at signalized intersections. For WB3, North US 40 would not need to be widened since there would be a new parallel road. Existing US 40 would still have a raised median and added turn lanes at signalized intersections. Both would connect to US 189 at Southfield Road, and there would be no changes to US 189. We have 2 other at-grade options, WB2 and WB4, that are the same as what we just reviewed with WB1 and WB3, but with a variation on the south end at the US 189 connection. Instead of using US 189 on its current alignment, it would instead be rerouted to run along the west edge of the sewer farm and 1300 South. The existing road might remain in place, but it would not be designated as US 189, and most of the traffic would be directed onto the new western corridor. This slide compares the free flow options for alternatives WB1 and WB3. For both free flow alternatives, vehicles traveling northbound on US 40 would need to stop at 1500 South, but then would be able to travel all the way to I-80 without stopping. Likewise, traveling southbound from I-80, vehicles would not need to stop until 1500 South. Vehicles traveling northbound on US 189 would need to stop at 3000 South, but then would be able to travel all the way to I-80 without stopping. Likewise, vehicles traveling southbound from I-80 to US 189 would be able to travel through the valley without stopping until 3000 South. Similar to their at-grade counterparts, the main difference between these 2 alternatives is that WB1, shown on the left, includes improvements on existing US 40, and WB3, on the right, includes a new road all the way to about Potter Lane. Both of these alternatives include an interchange at SR 32. WB1 also includes an interchange at Potter Lane and College Way, Coyote Canyon Parkway, and directional ramps at 900 North. There would be frontage roads along North US 40 in some areas to provide access between the interchanges to local roads and existing homes. The frontage roads would not be continuous. WB3 includes directional ramps tying to the western corridor into North US 40 near Potter Lane. South of where WB3 ties in, US 40 would have 2 lanes in each direction with signalized intersections at Potter Lane and College Way, Commons Boulevard, Coyote Canyon Parkway, and 900 North. The free flow alternatives generally follow the same alignment as the at-grade ones, with a couple of exceptions. The at-grade alternatives tie into US 40 at River Road, whereas the WB3 free flow alternatives tie in to US 40 near Potter Lane. In order to maintain connectivity with the SR 32 and meet design standards, the WB3 free flow alternatives need to tie in to US 40 about 1 mile south of the interchange with SR 32, which puts it in around Potter Lane. The connection to US 40 south of the hub intersection is also different for all free flow alternatives compared to all the at-grade alternatives due to design speed, design standards, and intersection spacing requirements. The at-grade alternatives were designed for lower speeds, and the alignment was based on spacing needed for signalized intersections. The at-grade alternatives would transition between 1300 South and 1500 South. The free-flow alternatives are designed for higher speeds and require straighter alignments and don't need to meet signalized intersection spacing requirements. These free-flow alternatives would align more closely with 1300 South. This slide compares the free-flow options for WB2, shown on the left, and WB4, shown on the right. These alternatives are the same as what we discussed with the WB1 and WB3 free-flow options, except they would realign US 189 on the south end to follow the west side of the sewer farm and 1300 South. The existing road might remain in place, but it would not be designated as US 189, and most of the traffic would be directed onto the western corridor.
We used the same screening criteria that were used in 2023, but looked at some measures in greater detail. There are 3 steps where alternatives can be eliminated, which are preliminary evaluation, level 1 screening, and level 2 screening. In the preliminary evaluation, we determined if alternatives have fatal flaws and should be eliminated for reasons other than level 1 and level 2 criteria, which we'll discuss a little bit later. We evaluated the 8 alternatives for fatal flaws or redundancy with other alternatives to determine whether they should be further developed beyond this preliminary level and advanced to level 1 screening.
This graphic shows the 2 options we considered on the south end, where the new corridor ties into US 189. 4 of the 8 alternatives would use the existing US 189, shown on the left, and 4 would realign US 189, shown on the right. For realignment, US 189 would follow the blue line, in effect forcing travelers towards the western corridor. The red line would no longer be designated as US 189 and could become a local road because there are a couple of properties that still need access. This table shows key metrics we considered during the preliminary evaluation for alternatives that realign US 189. We compared the travel times on the western corridor as well as on Main Street between SR 32 and at River Road and US 189, and between SR 32 and South US 40. The results show that realigning US 189 doesn't have a substantial benefit to regional travel times on the corridor or on Main Street, so we considered the alternatives that realign US 189 to be redundant with their counterparts that do not. In addition to providing no obvious traffic benefits, there would be negative effects from realigning US 189. Realignment would increase traffic on 1300 South, which abuts a residential neighborhood. For the at-grade alternatives, traffic volumes would increase from about 7,000 vehicles per day on 1300 South to almost 19,000 vehicles per day. We expect a similar increase for the free-flow alternatives if we realigned US 189. Realigning US 189 would also result in similar or greater impacts to the sewer farm compared to using US 189. For the free-flow alternatives, there would be almost 16 additional acres impacted by realigning. To recap, we considered the alternatives that realign US 189 redundant with their counterparts that don't because they perform comparably with respect to traffic operations. There would be negative effects with realigning US 189, such as more traffic on 1300 South, greater right-of-way impacts, including 1 additional residential property acquisition, more sewer farm impacts, and a higher cost. To maintain local access, we potentially would need to keep the existing US 189 segment in addition to the realignment, and that would result in 2 roads to maintain. So, we eliminated the 4 alternatives that would realign US 189 during the preliminary evaluation because there were no compelling benefits that would warrant the extra impacts, effort, and cost. The 4 alternatives that use existing US 189 were carried forward to Level 1 screening.
Level 1 screening is used to evaluate how well alternatives meet the purpose and need, which is to improve regional and local mobility on US 40 from SR 32 to US 189, provide opportunities for non-motorized transportation, and allow Heber City to meet their vision for the historic town center. I'll discuss these criteria and the measures we're using in more detail, starting with mobility. Mobility is the ease and efficiency with which people and goods can move from one location to another. Regional mobility is focused on through traffic, or traffic whose destination is not Main Street, from SR 32 to US 189 and South US 40. Measures for this criteria include travel time on the West Corridor and the number of conflict points. Conflict points are the number of intersections and driveways which impede mobility and decrease safety. Local mobility is focused on downtown Heber and Main Street, and our measurements are related to local traffic performance. Specifically, we're looking at PM peak hour operations on Heber City Main Street, which is typically between 5 and 6 p.m. Our measurements are level of service, or LOS, travel time on Main Street, and queue length. Level of service describes how well traffic moves on a roadway or at an intersection and considers factors like speed, travel time, density, how close vehicles are to each other, and delay. Traffic queue length is a measurement of how far back a line of stopped vehicles extends from a specific point. We're looking at the southbound queue length at 500 North. All alternatives that pass Level 1 and 2 screening will be refined with additional engineering to include bicycle and pedestrian accommodations that are compatible with local planning documents. Heber City's vision is focused on downtown Heber, and one of our criteria for the alternatives is being compatible with the city's vision for the historic town center. Heber City defines their historic downtown center as the area between 300 North to 300 South. These boundaries and vision are defined in the Heber City Envision 2050 plan. Compatibility with Heber's vision for Main Street includes lowering speed limits, pedestrian and bike-friendly design, landscaping, and being a gathering place for the community. Other measurements we're using include impacts to historic buildings and valued places like the urban parks on Main Street.
Similarly to preliminary screening, we use the same criteria that were used in 2023, and none of the original screen criteria were removed or replaced, but we looked at some measures in greater detail. The measures we looked at in greater detail included regional travel times and conflict points. To measure regional travel times, we used additional origin-destination pairs, which tell us where people are coming from and where they're going to. In 2023, the regional travel time between SR 32 and US 189 was a Level 1 screening criterion. For rescreening, we also considered travel times between SR 32 and South US 40 and compared travel time on the corridor to travel time on Main Street. The other measure we looked at for Level 1 was conflict points. After the last round of screening, MAG published a safety action plan and identified US 40 as part of the region's high injury network. Safety has always been incorporated into the alternative designs, but with the increased traffic and recent safety analysis, safety has been elevated as an important differentiator for screening. Conflict points were previously considered for regional mobility, but they are now considered as an important differentiator for safety as well. This table shows the Level 1 screening results, and a key takeaway is that all the alternatives would be an improvement over the no-action alternative or doing nothing. They would all perform comparably with respect to local mobility. There would be no failing intersections on Main Street in downtown Heber, and travel times on Main Street are similar within 30 seconds of each other. Vehicle queue lengths are generally similar, except WB3 free flow is slightly longer, and there would be one failing segment on Main Street with the free flow alternatives between Center Street and 100 South. However, we're not considering this as a fatal flaw because it's a short segment, and even without congestion, vehicles don't have much of an opportunity to accelerate to higher speeds to qualify for a higher level of service. Regional mobility is where we see more meaningful differences between the alternatives. If we look at WB1 at grade, for example, we see that southbound travel to US 189 would be about 3 minutes faster on the free flow alternatives, or about 33% faster than the at grade alternatives. Overall, the free flow alternatives are about 30 to 40% faster than their at grade counterparts in the southbound direction. In the northbound direction, the free flow alternatives are about 30 to 50% faster than their at grade counterparts. What these times show us is that free flow options are the best for regional mobility because they are substantially faster than the at grade alternatives. The at grade alternatives don't meet the purpose and need nearly as well as the free flow alternatives. The at grade alternatives would be the slowest for regional travel times and therefore less likely to attract truck traffic off of Main Street, and are also not as safe as the free flow alternatives. There would be only one conflict point with the free flow alternatives compared to the 12 with the WB3 at grade and up to 35 with the WB1 at grade. The at grade alternatives would also not be as forward compatible as the free flow alternatives. What we mean by forward compatibility is that it is likely that the at grade alternatives would need to be replaced with free flow alternatives at some point in the future due to the continued population growth and development in the valley. Having to retrofit the at-grade improvements with grade-separated ones would result in additional costs and impacts to reconstruct. Taking all this into consideration, we eliminated the at-grade alternatives and advanced the two free-flow alternatives for WB1 and WB3 to Level 2 screening.
The purpose of Level 2 screening is to eliminate alternatives that perform similarly in meeting the purpose of the project compared to other alternatives, but would result in greater impacts to key resources. The key resources we evaluate at this level of screening include waters of the U.S., Section 4F, property impacts, and cost. Waters of the U.S. and Section 4F resources are important for screening because of the federal laws that protect them. Waters of the U.S. include wetlands, creeks, streams, canals, ponds, and ditches. Section 4F resources include significant publicly owned parks and recreation areas, as well as historic sites eligible for listing on the National Register of Historic Places. It is important to note that impact evaluation during Level 2 screening is different from the detailed evaluation that will come after the screening process is complete, which we'll discuss a little later. As with preliminary and Level 1 screening, we use the same criteria that were used in 2023, looking at some measures in greater detail. Since the last round of screening, we have become increasingly aware that it will be expensive and difficult to mitigate impacts to the sewer farm. Right-of-way impacts to residents and businesses were previously considered in Level 2 screening, and for rescreening, impacts specifically to the sewer farm were considered as well. For rescreening, we are now considering archaeological sites as Section 4F resources. For this project, archaeological sites include historic canals, railroads, and ditches.
This table shows the results of Level 2 screening, where we only evaluated two alternatives, the WB1 and WB3 free-flow options. WB1 would have fewer impacts to waters of the U.S., including canals, ditches, streams, and wetlands. WB3 would have fewer property impacts, including historic structures, but greater impacts to archaeological sites, specifically historic canals, ditches, and railroads. Neither free-flow alternative was eliminated as a result of Level 2 screening, since they both include impacts, just different kinds. Both will be carried forward for detailed evaluation in the Draft EIS. There are trade-offs between the two free-flow alternatives that warrant additional review that will be conducted in the Draft EIS. This review will also provide more information for the public to consider during the Draft EIS public comment period. Moving forward in the EIS, these alternative names will be simplified. Because only two Western alternatives will be advanced, the names no longer need to be described by location. Alternative WB1 free flow on US 40 will be called Alternative A. Alternative B3 free flow with a northern extension will be called Alternative B. We'll walk through the design of the three segments of both alternatives. Both alternatives include a multi-use trail, freeway-style interchanges, and while there will be local access over or under the route to and on existing roads, access to the corridor is only provided at interchanges and free-flow connections. Alternative A and B are largely the same everywhere, except between Potter Lane and 900 North. A is on US 40, and B is in the north fields between Potter Lane and 900 North. The cross-sections on US 40 is slightly wider than the cross-section on the Western Corridor because frontage roads are needed on US 40 for local access. The Western Corridor would be 250 feet wide, and US 40 would be about 230 feet to 325 feet wide, and both roads would be wider at the interchanges. The speed limit would be 65 miles per hour on the Western Corridor and 55 miles per hour on US 40. Alternative A uses US 40 for a longer distance, so the travel time is not as fast as Alternative B, which uses the Western Corridor for a longer distance. The speed limit for east-west connections at 900 North and 1300 South is 45 miles per hour for both Alternative A and B. As we discussed earlier, 1300 South is a critical connection to the West Corridor and is included in both alternatives. The cross-section at 1300 South would be 160 feet to 185 feet wide. The inside lanes are the Western Corridor through lanes, and those would be elevated with bridges over Daniels Road, US 189, and 300 West. The inside lanes would be elevated between US 40 and Industrial Parkway. The outside lanes would be one-way fringe roads between US 189 and the sewer fields to provide access to local roads including US 189, 300 West, and a right-in, right-out at Industrial Parkway. Moving forward, We will refine the design of both alternatives and then perform additional analysis. Design refinements are to address access, drainage, and stormwater management and avoid impacts to key resources where possible to support detailed analysis in the Draft EIS.
In addition to design refinements, we will be looking at potential impacts in much greater detail than we do in the screening process. Our detailed analysis will be evaluating the potential impacts to nearly 20 resources that include what you see on screen and several more, including economics, property, traffic and transportation, considerations related to pedestrians and bicyclists, air quality, noise, water resources, ecosystem resources, floodplains, cultural resources, hazardous materials and waste sites, visual resources, and open space.
To wrap up, I'd like to walk through our schedule. Currently, we completed screening and are working on the design refinement and detailed impact analysis that Naomi just described. Once this analysis is complete, we will identify the preferred alternative and publish the Draft EIS, which we expect to be sometime this fall. When we publish the Draft EIS, we'll be holding public hearings and a comment period to get input from the community on our analysis and the study recommendations. While we're working on the Draft EIS, we will continue to provide updates at the Heber City and Wasatch County Council meetings. So I encourage you all to watch those presentations and sign up for our email updates or join our Facebook group to stay informed.
For more detailed information on what we've reviewed in this video, please visit the study website to review the full report and traffic analysis.
Thank you for watching. We appreciate your time and look forward to seeing you at one of our public meetings.